Hello everyone. In this video, we will be solving the question iterative pre-order and post-order of generic tree. So we're familiar with the recursive solution for this particular question. In this question, we'll be solving it iteratively as it suggests. So let's see how we're going to do that. Say we have a tree with the nodes 10, 20, 30, and 40. And we can have two more, say 50 and 60. We're supposed to solve this with in an iterative fashion, and we can do that with the help of a stack. See, if we draw a stack right here, right, so in the stack we'll store our values. Now what value are we supposed to store here? That value could be a node that we have and its state. We have a node, we can have its state. This state will basically help us determine which type of order that are we supposed to follow at the moment, that is, whether it is pre-order, whether it is post-order, what is it exactly, right? So the reason behind that is that when we traverse through an array, say in this fashion, in an Eulerian path, or Eulerian, however you choose to pronounce it, we travel 10 to 20, then we go back up to 10, then we go to 30, then we go back to 10, then we go to 40, then we go back to 10. You see, we keep going back to the root before going to the children. Of course, I made a mistake here. After 30, we go to 50, then we go back to 30, we go to 60, we go back to 30, then we go back to 10, then we go to 40, and then we go back. Sorry for the messy diagram, but that's basically the concept. And that is what we'll use to perform this iterative function, in the sense that first we go with 10, we put our value 10 here. Say, let me just draw a partition. Start in green. We have a partition here, and we will store our node and our state in this stack in the form of a class. We'll make a pair class which will have our node and our state together. So we have 10, its state, the corresponding state now. I say that let's keep it as -1. And if it is as -1, that means if it is -1, it means that we are in the pre-order stage. And let me also keep building up my answer here, pre and post. Let me keep building up my answer. What I'm going to do, I'm going to take out the value which is at the top of the stack, which is 10 right now, and I'll process it for pre-order. So it has been processed, it's been kept here. Once that is done, I say that you increase the state to 0. You increase it by 1, basically. And if this state is not equal to size, by size I mean the size of the list of its children. This size in this case would be 3, 1, 2, and 3. So if the state is -1, we do pre-order. If the state is equal to children dot size, which we'll use in a bit, then we do post-order work. If the value is between these two values, that is, it could be 0 to size, -1, anywhere in this range, in both of these included, we do pre-order work on the children. And how do we decide which child to work on at the moment? The state will decide that. For example, if our state is 0, then we work on the 0th child, that is the very first child right here. If the state is 1, then this one. If the state is 2, then we work on this child. If the state is 3, we do post order work. That's the approach we are going to follow. So let's try run this. Then now that the state has been increased, and also for pre-order we increase our state by 1 after we process it, and after working on the child we increase the state by 1, but we don't do that for post order. We'll see that in a moment. So now that it has been increased, the next step is to actually, and that the state is 0, we do pre-order work on the children. The first child is 0 since the state is 0, and the child itself is 20. Its state would be -1 for pre-order work. So we do pre-order work on this child 20. 20 does not have a child, does not have any children. State has been increased after pre-order work, and so it now reaches its child dot size value, which is 0 since it does not have any children. We do post order work on it. We do post order work, and then we remove it from the stack. We remove it from the stack completely because its work now is done. Then we go back up to 10. We increase its state once again to calculate our next child. Next child is 30. We keep it here with the state as -1, and we do pre-order work on it. We see our 30. We check its children. We go to the 0th child. Of course, after pre-order work, we are supposed to increase its state. We go to the 0th child now. We put it here. We go in this fashion. We do pre-order work on this child. We increase the state to 0, which is equal to the number of children this node has. So we do post-order work on it. I hope you're able to follow this. If not, I suggest you rewind and then watch this again, because this is a very important step. Then we simply remove it because its work here is done. Then we go back to 30. We go back to 30. We increase the state to 1 so that we can now go on the first child. We had the 0th child, now we have the 1th child, or the first child, however you wish to call it. Now I have 60 with me. I push it and allow it to do pre-order work. And then it does a post-order work after increasing its state to 0, as that is the number of children. Then I remove it. I go back to 30, I increase the state to 2. 2 is the number of children 30 has, and so I pop it and do post-order work, and it has been popped from the stack. Now I have 10 remaining with me on the top of the stack, so I increase its state. I've done 0th child, I've done first child, now I'll do a second child. Second child, I go to 40, I put it here. Pre-order work is -1, pre-order work is 40, pre-order state is -1. After pre-order work, I increase the state, which is equal to the number of children 40 has, so I do post-order work on it, and then I pop it, as I've done with the other nodes. Now I finally go back to 10, I increase the state, and now I simply see that the number of children, that is 3, is equal to its state. So I can now do post-order work on 10 and then pop it. And that is basically my pre and post-order answer that I'm supposed to print. So let's try to implement this particular approach. Let's go to full screen. Okay, so we have a function with us. We're supposed to implement our answer in this function. So let's say stack. This will be of type pair. St is equal to new stack. Stack has been defined, which we'll be using to do our work. Now let's have a pair class. It has the node, it has the state. And then we need a constructor to initialize it. And we are done with that. So we're going to start off by putting our root in the stack. We make a new pair, put our root in it with the state as -1. We already have our node class. Feel free to open the portal yourself and see what exactly does it consist of. Well, I'll tell you in brief. That consists of data value and the array list, which I'm sure you've seen by now if you've solved the previous questions. If you haven't, I suggest you do that. Now I check. Now I run a loop till my stack is empty. And I check whether my first I take out the element which is at the top of the stack, which is to be processed right now. So at the top of the stack, I have a pair. I check if the state at the top is equal to -1. If it is, then we do pre-order work as we discussed. And to do pre-order work, we also need a string or a string builder. I am choosing to do it with string builder. Let's hope I don't mess that up. Okay, new string builder. String builder for post order. The state is -1. I do pre-order work. I append it. I append the data of my node with a space, which is the required formatting for this question. Then I increase the state. Top dot state plus plus. Now it will work on its children. Now this case, else if top dot state is equal to top dot node dot children dot size. We check the number of children that we have, and if our state is equal to that, we do post order work. We put a space and we simply pop our value because it is of no use to us anymore after this. Otherwise, we work on the children. We are in the range of our children, so we can work on it. But for that, we will simply add a new pair to our stack, and the value for that node would be, well, top dot node dot children dot get top dot state. This is the particular child. The value of the state is the particular index of the child that we want right now, and we have to do pre-order work for that particular child. So that's what we'll do, and once that is done, we increase the state of our current variable. And after that is done, we simply print our pre-order and post-order results. And let's check if our code is producing any errors or not. This is the code. Let's see if it works. And okay. Line number 50. It's expecting something, or the data type, of course. And we'll have to actually print this inside our function, not outside, as soon as we're done with the work. I missed a bracket apparently. I do that a lot. And I think I missed something else. Oh, we don't want to push the root anywhere. We want to push our node. That node initially would be the root itself, so that's a different thing. And I made a spelling error apparently. Lots of compilation errors to deal with, and of course that's what happens when you try to code and there's another one. Okay, so top.data is not accurate. Top.node.data is what we're looking at right now. And I can see another spelling error. And let's hope that the code runs this time. It's accepting finally. And let's try to submit it and see if our test cases are passing or not. And it is. And that's basically how you solve the pre-order and post-order traversal of a generic tray in an iterative manner. If you found this useful, feel free to leave a like, drop a comment, and subscribe to our channel. Thank you so much for watching.